Welcome to this particular class. In this class, we will see the substrates that are used to fabricate these biomedical devices, because as the name of the course suggests, that we will be looking at the mathematical aspects of biomedical electronic system design. You should understand what are the biomedical systems, and if you understand what are biomedical systems, then you will understand that what are the different parts integrated into a particular system. Now most of the system that we develop that has either a sensor or an actuator, right? So if I talk about micro sensors, then how to integrate or how to design and fabricate those sensors is something that is of importance. Now to do that, we will see where exactly this fabrication happens, what kind of laboratory environment you require, and then we will also see what are the substrates that are used to fabricate those sensors. Substrate is a base material on which you can fabricate different layers so as to realize a sensor, right? So if you see the slide, this topic will cover introduction to clean room and overview of microfabrication process. So as you can see in the slide, whenever you want to enter a clean room, it is very important that we avoid as much contaminants as possible, and the way to avoid contaminants is by following the clean room protocol. When you talk about clean room protocol, the first thing and foremost thing is how to wear the gowns, how to wear clean room hood or gown, and then how to wear the gloves. It can be safety glasses, cap, hood, face mask, boots and shoe covers. This all comes under PPEs or personal protective equipment. Now once you understand the process of how to enter the clean room, you will see that that within the clean room there are several equipment such as thermal evaporation, EVM operation. There can be sputtering, CVD, which is PCVD, LPCVD, MOCVD. There would be oxygen plasma systems. There would be chemical benches for wet etching and dry etching. Then there would be a parallel deposition system. You will find a photoresist spin coater, you will find a mask aligner or photolithography system. It can be front lithography, or it can be front to back alignment and do perform lithography. Then we also have the RIEs, which is a dry etching, either it is reactive and etching for chemical. Using chlorine, it's called chlorine etcher. If it is using fluorine, it is called reactive and etching for fluorine. And then the final is you will see in a clean room a deep reactive ion etching system. Again, all the things that I'm talking about are the technology, are the equipment that you will find when you are inside the clean room. There is a role of each equipment at certain point of time, and I'll try to cover few of the things, and then we will associate those things with the theory and see that how the understanding of mathematics will help us to understand the design and fabrication of devices. So having said that, a few of the similar world-class facility you will see around that we have at IISc are from Berkeley. You can see they have about 11,500 square feet of 10,000 clean room facility, and it's a unique facility which works on biomedical, micro electromechanical systems, and of course microfluidic devices. They work on medical diagnostics, analytical chemistry, proteomics, genomics, cell biology. Then we have another lab in Israel, Weizmann Institute of Science. These are some of the clean room laboratories that I'm talking about. The reason of showing you this particular slide is to make you understand that there is a huge investment in this particular research area, particularly as it is linked with the healthcare technologies. And when you talk about healthcare technologies, all these healthcare technologies would have at some point of time they use sensors and they use actuators or transducers. All right. So there is another nanotechnology center from Purdue. It's called BIRCK. I'm sorry you cannot see the full screen, but it is a BIRCK. And from Fuji Electric, they have a Fuji FUGI BioClean. This is a clean room that they have. The entire building is a clean room. All right, so it's a world class facility that we have. What I'm showing in this slide. However, the point of showing you this slide is also to make sure that the same things we have at Indian Institute of Science, And if you go to the IISc website and clean room facilities, you will see the similar kind of facilities we have, everything under one roof. Having said that, let us come to the actual terminology, and the terminology that we will be utilizing in this particular course would be on micro and nano. The micro means one meaning is 1 millionth, or in the another terms you can say 10 to the power minus 6. When you say nano, it is meaning 1 billionth, or in another term you can say 1 to the 10 to the power minus 9. Now if I want to give you a very simple example of microns, then I'll just show it to you in the next slide. However, just quickly understand that this micro and nanotechnologies are used in several areas, from molecular manufacturing to nanotubes to medicine, nanocomposites, and finally electronics, whether you talk about advanced CMOS, silicon transistors, or microfabricated devices for several applications like pressure sensors. Then we have actuators, which we can piezoelectric actuator or piezoresistive actuators. We can develop transducers like PMUTs or CMUTs, and so on and so forth. So as I said in the last slide, that how exactly or how large is 1 micron. So human hair is close to 50 to 70 microns, and that is the thickness of a human hair. Okay, and then when we talk about pollen, it is about 30 to 50 microns. Dust mite is about 10 microns, and ragweed is around 17 to 23 microns. So if I talk about 1 micron, you can see the dot that you see on this slide, this dot, right, white dot within this red circle is 1 micron. Now comparatively, within 1 micron, in today's with today's technology of developing several transistors, we can accommodate billions of transistors onto this 1 micron. Single micron will have millions of transistors. So that means that if there is a dust, right, falling on this one particular 1 micron area, it will kill few transistors, right? It will kill few transistors. So that's why we should require a clean room facility. So now when you talk about clean room, again you have to understand that there is a integrated circuit, because half of the things in electronics that we see today are all IC based. And when you talk about integrated circuits, then you have to understand that integrated circuits are made up of the base material is silicon. Now we have different materials, and there are SOI wafers, there are gallium nitride wafers, and many more. But the base still remains as silicon. 90% of the industry still uses silicon as the base material or as a substrate. And if we are going to make different devices, then you can also use glass as a substrate, you can use plastic as a substrate. Then the silicon substrate, again if you want to divide into further steps, then there are 4 basic steps. First is the production of electronic grade silicon, second is the crystal growing, third is polishing of wafer, and the fourth one is slicing of silicon wafer. So right from the sand to silicon, what are the process, right? There are 2 techniques. If you have understood the if you already have an undergrad degree, or you are learning, we are in 4th semester or 5th semester, 6th semester, you must have learned the VLSI technology and design. In that you will see there are 2 techniques called the CZ technique, C and Z, and then there is FZ, right? So CZ stands for Czochralski technique, or flow, and FZ stands for float zone technique. Depending on the pronunciation, it will be different, but the techniques remains the same. That these are techniques to realize a silicon wafer right from the sand. So sand to silicon, what is the process? That is shown in CZ and FC technique. So you can see here the slide shows the left topmost slide shows the sand, right? This is a sand, and through sand, these are the glass crystals, and this is glass, right? Very easy to see. And what is this? This is oxidized silicon wafer. Oxidized silicon wafer. That means you have a silicon wafer. If I draw a cross section of this wafer, right, it will be the one that I am showing you here, right? Silicon. Now if you do a oxidation process, we'll look into oxidation process in either this class or another class. You will understand that when you heat the wafer at 1100 degrees centigrade, and if you pass oxygen and oxygen reacts with silicon, it gets SiO2. So silicon plus O2 gives us SiO2. This is dry oxidation process. Now there is a wet oxidation process in which you have silicon plus H2O gives you SiO2 plus H2. Now you see we have to balance the equation, so you said 2H2O, right? So you have SiO2 and H2 gas comes out. This is when you use water vapor to grow silicon dioxide. Silicon plus oxygen, this is a dry oxidation because here there is no water vapor. In the second equation we use water vapor, that's why I say Si plus 2H2O gives SiO2 plus H2, right? And then what you see further is that we will now show a thermal oxidation technique in which you can grow the silicon dioxide layer onto silicon substrate. So when you grow silicon dioxide layer onto silicon substrate, you will see like this. This is your silicon dioxide, and the silicon is there. So the wafer that you see in this particular picture, let's say if we name it the first one, second, right, third and fourth, then the fourth picture that you see here, right, is an oxidized silicon wafer. Let us go to the next slide. Okay, these are the racks of silicon wafer, rack of silicon wafers all stacked together, and it can vary from 25 to 50 depending on how many silicon wafers you can you want to oxidize in one time. You can do oxidation of all the silicon wafer in one go in something called or in a process called thermal oxidation, which uses horizontal tube furnace. So we will see that process. Here you need to understand that how the silicon wafer looks like. Alright. Now why we are again looking into this particular system or the techniques is to understand that silicon will be used as a substrate to fabricate several devices, and once you have devices you can integrate those devices into biomedical systems, and then we will look at the mathematical aspects of how we can use different basics of the math into this biomedical system to understand the several important properties into healthcare. Alright. It can be a tissue property, it can be a cell property, when you use AC versus DC, how the properties would change, how you can create a model, how it can fit with the data, and lot of understanding about those aspects. But before that, if you take any integrated circuit, you will generally find that when you open this integrated circuit, this is a casing, right. This one is a casing. If you open the casing, what you will see is that there is a small chip, right, which is on the integrated onto this particular casing, and then there are wires like this connected to the external lead. These wires are nothing but wire bonded, right, to the external lead, and this wire bonding is done by something called wire bonder. As the name says, wire bonding, wire bonder, right. So this connection to your fabricated chip is done through the wire bonding mechanism. There will be wedge bonding, there will be the different kind of bonding mechanisms, but you cannot do soldering or press fit contact in this case. You have to rely on wire bonding. So once you bond the wire, these are your external leads, lead 1, lead 2, lead 3, that you use for different processes, right. So what we see further is that when you want to use silicon wafer as a substrate, it sizes from from 2 inch, the dimension changes from 2 inch all the way to 18 inch. Now when I talk about 2 inch or 3 inch or 5 inch or 6 inch, 8 inch, 4 inch, 12 inch, 18 inch, what does I mean? I mean that the inch says about the diameter of the wafer. Okay, what is the diameter of the wafer? So for example, if you take a 4 inch diameter wafer, and if I see the cross section of 4 inch diameter wafer, the thickness would be close to 500 micrometer. Alright, the thickness will be close to 500 micrometer. This is we are talking about the thickness of silicon wafer, 4 inch silicon wafer. That means that if I take silicon wafer and if I measure diameter, it will be 4 inch. 4 inch diameter. So this is what it means, and then the photo shows different kind of wafer size available in market. Now as I told you that to fabricate these devices we have to have facility which is called clean room, and is a facility ordinarily utilized for doing research, for cheap manufacturing and industrial production of microfabricated devices. It is also used heavily in pharmaceutical industries to create drugs. And when we also talk about clean room, you also have to understand that it is a facility that controls the particle count, contaminants, relative humidity to achieve more efficiency in fabrication of devices, and of course with repeatability, efficiency both goes hand in hand. If there is no repeatability, there is no point of having more efficient process. So that is what we are talking about. If you see again in this slide, I do not think you can see on the right side. So can you just move me out please on the slide. Avinash, can you please? Yeah, thank you so much. So here you can see that depending on the particle count, the clean rooms are categorized as shown below. Generally it is categorized based on the particle per cubic feet, and it goes depends on the particle per cubic feet, either is 0.1 micron particle or 0.2, 0.3, 0.51 and 5 micron particles. And you can see that as you go towards the lesser number, that means class 1 is cleaner than class 10, class 10 is cleaner than class 100, and class 100 is cleaner than 1000 to 10,000 to 100,000. So in class 1 and class 10, as you can see that almost 5 micron particle is not existing, 1 micron is just 1, 0.5 micron is 1, and then 0.5 micron in class 10 is 10, in 0.3 micron 30, 0.2 75, 0.1 350. But the purpose of showing you this slide is to understand that the clean rooms are further divided into several classes based on the particle per cubic feet, right, and depending on that there are several standards, right, from ISO 1 to ISO 9, and ISO 3 is for class 1 environment, ISO 4 is class 10, and ISO 8 is for class 100,000 environment, ISO 9 which is just a clean room air. That means that if you go to a clean laboratory, right, and the air that you find it out hoping that it is clean, right, you can give the laboratory ISO 9 certification in terms of class. But when you want to create a clean room, you have to make sure that the particle counts falls within this particular parameters, so as to make sure that the device is not the chip is not deteriorated, the contaminants are minimum. Now having said that, when you work in a clean room, we will just quickly see this slide so that you understand that the working and the protocols of the clean room. What you do not have to do, that is very important. See, in most of the subjects that you take, it is very important to understand what not to do also, right, and what to do. So if you are in the clean room, you cannot wear makeup, or you can not wear sandals, right, you are not allowed to bring coats, hats, backpacks, bags, all these items should be stored in the office or the lockers outside the clean room. You cannot wear dirty clothes, particularly muddy boots or shoes. Never unzip a clean room gown to retrieve an item from the underlying garment, right. Always follow the lab protocol, and safety is very important. Now if you want to create a clean room, the question should be, how can one create a clean room or class 10 or class 100 kind of clean room facility? So the answer to the question is by using a filter called HEPA. HEPA stands for high energy or high efficiency particulate air filter, and is one of the most important component of the clean room. And the way the HEPA filter works is by absorbing the particles at the air inlet of the clean room, and this supplies the filter air through the clean room to maintain temperature, pressure, humidity. Another thing is very important in the clean room, if you see, it's a air shower. When you enter the clean room, the air shower will help to bombard the person with a flow of filter air, and this in this bombardment will result in dislodging the particles. It can be dislodged also foreign objects, it can dislodge skins and clothing and so on and so forth. Then another thing, that when you see the clean room, I think I will just send you a video of how the clean room looks like, how to enter the clean room, what are the protocols within the clean room, how the pass box works and everything. So for now, just understand that when there is a pass box is used for passing the material from one side of the clean room into other side of the clean room. So if you wear all these gowns, right, the whole clean room hood and then you don't have to if you don't want to go inside, you can open the pass box, put your item, close this door, let the person inside, open the another door, and that person can retrieve the material. So it ensures the that only one door will be open at one time, and thus the passing of the material is possible. Next one is about the airflow, and you can see in this particular schematic that the airflow which is a laminar clean room flow is very important. In this case the air is introduced and recirculated in clean room after removing dust from the HEPA filters. You can see here the air comes from here, it passes through the HEPA filters, right, and usually the filters and ducts are made up of stainless steel, and to ensure minimum number of particles. Also separation of particles from the air during recirculation of air is difficult, and that is why it will create due to the turbulence, right, because if you send it back it will create a turbulence. So to avoid that, it is only unidirectional flow is allowed and multidirectional flow is not allowed. So if you see, the unidirectional flow is shown here, right, to avoid the turbulence. And the next slide, when you see that what are the clean room parameters, you will see that the particle count is one of the very important parameter, along with the relative humidity, which generally lies between 30 to 40%. We also have the narrow band of plus minus 2%, that means it can go to 33%, it can go to 42% or 38% or somewhere in that range. So plus minus 2% is allowed. So the point is 35 plus minus 2, 40 plus minus 2, right, and the important factor is that you have to strictly maintain the temperature also. Generally it is below 20 degrees centigrade, in between 16 and 19 degrees centigrade. Now if you talk about sources of contamination, there are several sources of contamination. The biggest source is the person working inside the clean room, alright. So and this contamination generates from several things, right, from the materials that we use in the clean room, which can be aerosols, which can be water, it can be cleaning chemicals, wipers, tape, dusters, stationery, and many more things. It can generate out of degassing, evaporation of chemicals when we use wet benches, when we go for physical vapor deposition like sputtering, e-beam, thermal evaporation. We will see and understand some of those in this particular course as well. Finally, the tools that generates because of the friction generation, particles, lubricants, and finally the people that are working inside the clean room because of the oil, perfume, cosmetics, hair, lint and fiber from clothes. These all are the sources of contamination inside the clean room. So as I told you earlier, the restricted materials within the clean room are right from the paper, pencil, fabrics, wet and dirty clothes, loose clothes, dangling jewelry, everything is not allowed, right, within the clean room. The gowning procedure, I will send you the video, just you look at here. Now I am sure that most of us we know how to wear a mask, right. It should be above the nose, not covering your eyes of course, and it should cover your mouth. Then you have a hair net, and then you have a gloves, you also have a safety glasses, a clean room shoes and a gown, right. So there is a gowning procedure, gowning and PPE. PPE stands, as I told you earlier, it stands for personal protective equipment. So gowning procedure should be strictly followed for the person's safety as well as to save the fabricated device from human generated contaminations. You understand that if there is a loose clothing, there is an entanglement hazard. Secondly, wet hair net, lab coat, gloves and booties. You can see that all these things would be there within the clean room. And once you wear everything, more or less this is how the person should look like when he or she is wearing a clean room gowns, right, and along with the PPEs. So further in PPE we have to also understand the face shield, we have to understand the mask, the gloves, right, safety glasses, and the face shield is used when we go for the wet etching. Generally when there is a acid bench, there is extra protection that we have to take. Same thing, we have to wear different kind of gloves, particularly when we work in the acid bench environment, right. And another thing that we need to understand is that working at a wet benches, you have a 3 different kind of gloves. One is nitrile gloves, another one is MAPA gloves, and last one is the F Teflon gloves, while the latex and vinyl gloves are not allowed inside the clean room. So, the few more slides on understanding the safety issues, because it is very important whenever you understand a biomedical system you should understand what are the safety hazards, and it starts from the MSDS, which stands for material safety data sheet. All the chemicals that you used, all the materials that you used within the clean room or even in the lab would have a MSDS data sheet. You can see it, you can see the temperature, boiling point, melting point, depending on the material of course, and you have to be careful whether it is explosive or not, whether it is corrosive or not, whether it is flammable or not, right. If it is a gas cylinder, if it is a environment, then there is aquatic toxicity. When there is a acute toxicity, you will see a symbol skull or crossbones, right. When there is a exclamation mark, that means that there is a skin sensitizer. Acute toxicity is there. There can be respiratory tract irritant can be there, right. Hazard to ozone layer can be there, is the exclamation mark. Then the another symbol that you see, health hazard, which is right here, that will when there is a carcinogenic material inside, when there is a mutagenicity, when there is a reproductive toxicity, respiratory sensitizers, target organ toxicity, aspiration toxicity, then you have this kind of symbol. And finally, you know this symbol very well, is a flammable, it is a flame symbol stands for flammables, it stands for self heating, M is flammable gas, self reactive organic peroxide. So, these are all the symbols that more or less when you see in the lab you will know that this is for that particular that the lab has that those particular materials with that particular explosives or corrosive or flammable materials inside the ecosystem, and then you need to take care accordingly and wear the PPEs accordingly. Now, you have 4 blocks here, as you can see on the screen, right. The leftmost block, which is a blue one, right. The blue one shows that it is a health hazard and it can be deadly, extremely dangerous, hazardous, it can be slightly hazardous, or it can be normal material. If it is deadly, you give a 0.4. If it is extremely hazardous or extremely dangerous material, you can give 3. If it is hazardous, 2, slightly hazardous, 1, and normal material, then you can say 0. If it is red, it stands for fire hazard. If it is below 73 degree, then you say that it is 4. If it is below 100 degree Fahrenheit, then 3, below 200 degree Fahrenheit 2, above 200 degree 1, and will not burn, it is 0. Instability, the yellow one shows instability, whether it is detonate, then it is 4, shock plus heat 3, violent chemical 2, unstable if heated is 1, and stable is 0. This 4, 3, 2, 1, 0 that I am talking about is all the corresponding right from deadly to normal, alright. So, 4 is extremely deadly and then is normal, but in case of fire we have seen that what are the flash points, that if it is 200 degree, that means that before that it will not catch the flash, and that is why we have numbering like that. Okay. So, having said that, the last one that we have left here is a specific hazard, which is a white color box, and here you can see that it can be for oxidizers, alkaline materials, or you should not use any water, or simple aspartame, or it can be acid, it can be corrosive, it can be radioactive. So, then we use a white color box. Excuse me. Okay. Now, we talk to wet bench protocols. So, the most important thing is that in the wet labs, as you can see in the screen, right, you are not allowed to do this, alright. You cannot wear the PPEs and work in the wet bench with the mobile in hand and talking to someone. Next thing is you should never put your head within the wet bench, because what happens is there is a vapor, right, that because of the boiling of the chemical, that vapors we will breathe in if you will have the head within the wet bench. So, you have to take care of these issues while working in the wet benches. You see, it is not a storage area, right. It is a wet bench to perform the experiment. You should not store the chemicals like this, it is not allowed at all. So, and finally, you should never rub your eyes or touch your belongings wearing contaminated gloves. You always follow the MSDS data sheet. Do not put face or head inside the hood, very important, you should never do this, never, alright. do not use cell phone, and be cautious when you use chemical hoods. These are something that is very easy to understand, that we have studied in chemistry, right. The dilation of concentrated acid is exothermic and it releases heat. That means you should always add concentratic acid to water, do not add water into concentratic acid, otherwise it may explode. And always remember the AAA principle, that means that always add acid AAA to water, right. You should be careful while you are using the clean room environment. Finally, if there is a chemical spill, then there is a spill on floor or spill on person. If the spill is on floor, then you have to use a dilute with water and supply chemicals, chemical spill pillows, which are already available in the clean room. If there is spill on person, then wash under safety shower and seek medical attention. The most important or dangerous spill is HF spill. HF stands for hydrofluoric acid, and this spill is highly dangerous due to internal tissue and bone damage. You have to wash with large amount of water, removing contaminated gown, and then finally apply calcium gluconate gel and seek immediate medical attention. So, the last safety that we have to see is electrical safety. Now, I really want you to understand this thing, because when we will look at the clean room protocols and the fabrication process to for several devices, this all things comes at a later stage. First is how to work inside a clean room, what are the clean room protocols, what are the safety issues, and what kind of safety that we need to take care of before we start looking at the experiments, right. So, very important, it is not only for this course, it can be applied for many courses. In fact, wherever you are working in your lab environment, make sure that all the safety issues are taken care of. So, you can see that as many of the tools use high voltage supply, practicing the electrical safety is extremely important, right. This is absolutely not allowed, what you see here, right. Wet hand is there, and we are using the power, and then you can see there is a dangling wire, absolutely not allowed. Cut wire, not allowed. We generally try to do these things often, we have seen, you may have seen, but this is not a good practice to use the multiple things from one single source, right. Particularly when it is like this, broken, right, is hanging, it is not correct, alright. So, there can be danger when it is hazardous voltage, you will see this kind of symbol, right. If it is electrical hazard, you will see this, right. If it is you have to keep out from electrical hazard, then this is a symbol. Then severe shock hazard is this one, high voltage is this, right. No loose connection, right, and then you have a hazardous voltage. So, this is the symbol. So, the point is learning electrical safety, and of course, the all the other safety that we have discussed till now is very important part of this particular clean room protocol. So, we have to learn that. Fire safety, all of you now, I am sure that you know it. For those who do not know it, we cannot use any kind of fire extinguisher to to remove the fire, to extinguish the fire. So, the point is, if there is a fire, you have to trigger the alarm, leave the building immediately, do not return to the building until authorized, do not use elevators, use fire extinguishers, right. And in particular, symbols found on the fire extinguisher and what they mean. So, if you have a wood, paper and textile kind of material that is on fire, then you can use the fire extinguisher, which is your water. You can use foam spray, you can use the ABC powder, and you can use the wet chemical. You cannot use carbon dioxide if it is wood, paper and textile. Same thing, if I go for the flammable liquids, if flammable liquids catch fires, then I cannot use water, water is not allowed. I can use foam spray, ABC powder, carbon dioxide, and wet chemical is not allowed, right. Same way for flammable gases, electrical safety and cooking oils and fats. So, all things are on the slide, you can easily see, you can go back and look at the lectures and understand that how the things are done. When you use a fire extinguisher, always understand that is a term called pass, PASS. Pass stands for pull the pin, then aim the nozzle, right, squeeze the lever slowly and sweep from side to side, right. So, this is how it is written, pass, PASS. And then the very important point is biosafety hazards. So, when you work in a clean room, you will see biosafety hoods. These are called biosafety hoods, and its safety level is biosafety level 1 to biosafety level 4. right. So, you can see here depending on the experiments that we will perform, right, we will show it to you how biosafety level biosafety hood looks like, but it stands from BSL 1 to all the way to BSL 4. What we will show you is BSL 2. BSL 2 hoods we will show it to you as a part of this course, and you can see that BSL 2 are microbes that are typically indigenous and associated with diseases of varying severity, for example Staphylococcus. If I have BSL 1, then I can use some strains of E. coli, but if I have tuberculosis bacterium, which is called Mycobacterium, or if I am working with Ebola or Marburg viruses, then I have to go for BSL 3 and BSL 4 accordingly, right. If you want to use tissues, whether it is a heart tissue or it is a brain tissue, you can use BSL 2. PPE is for biosafety. If you see the task versus potential consequence for this additional PPE, you will understand that what are the tasks and what are the potential consequence for which you require the additional PPEs. It makes no sense for me to read line by line, because it is very clear from here that you have to understand what are the tasks and what are the consequence, and depending on that whether you would like to have the additional personal protective equipment or not. Of course, excuses are not acceptable. You have to follow lab protocol, and you should never make your own protocol, right. Some of the photos just to show that this is not a way to work. Finally, when we talk about microfabrication process, we will see several things, right from wafer cleaning to the oxidation process, which is thermal oxidation process. Then we will look at the deposition techniques, the photolithography technique, we will look at the etching, RI, DRI, and then bonding, dicing, releasing, and also we will understand right from concept to the fabrication to the testing, and then once you have the device and you use the device for certain application, let us say we want to understand the electrical, mechanical and thermal property of tissue, right, then what are the mathematical models that can be used for fitting the data, fitting the curve, and those things we will take it at a certain point of time. So, we will try to cover most of the things which are related to microfabrication process that are used to fabricate your devices, and having said that, this is the last slide of this particular class. In the next class we will actually start to use the silicon wafer, and I will show you how we can what are the process to fabricate those silicon wafers, and also we will take the concept of photolithography and the deposition techniques for metal deposition, semiconductor deposition and insulator deposition, and we will see how we can pattern different materials onto silicon substrate so as to realize either sensors or transducers in detail. Alright. So, till then you take care, look at this class. This is mostly like introduction to the clean room protocol, clean room safety, right, and the microfabrication process. So, till then you take care, I will see you in next class.